When CME2 first connects to the drive, it uploads all the parameters. Normally on a new amplifier, the basic setup screen opens and we can configure the amplifier for the motor that we're using. So we change the settings. This is a brushless motor of a rotary type. It has Halls and an encoder on the shaft of the motor and no secondary encoder. Position loop, we can change the mode of operation, and the source of the command we'll use digital input. Digital input is using the high-speed inputs, and I would like the motor port to be buffered out. The default commutation would be sinusoidal, and then we save to flash. The software is forcing us to start with the motor data, and here we could open up a file, or we can enter the data manually for the motor. This is an 8-pole motor, and these are all the parameters. The feedback is 2048 line encoder that gives us 8192 counts per rev. This motor has a brake on it, or we could set up the stop feature before the output's disabled. So there's the brake delay times, and when all the data is entered, we can create a file, a motor data file, or we can calculate the initial tuning parameters based on the good data. It calculates current limits and other parameters for gain. That's saved to flash. The first thing we should do with a new motor is Autophase. So let's release the brake here and turn the motor shaft, get some counts. This step of autophasing will rotate the current vector and verify that it sees counts. We can see the motor move, so it confirms the wiring of the motor. This step will check our assumptions of the counts that we entered and the number of poles, and we'll watch the motor for 1 rev. It will go through, on an 8-pole motor, it'll go 4 electrical cycles, and that should be about equivalent to 8192 counts. And if everything goes well, it will confirm the counts. Yes, the motor did rotate 1 time, so our assumptions of counts and number of poles is correct. The next step here is going to check the Hall decode for a given current vector rotation, and you can see it's going backwards. All the Hall states are changing, and it found 30-degree Hall offset, and it rewired itself to the motor. Let's look at that again to see a perfect commutation. There we go. The indicator rotates with the needle, and all the states are changing, so that's good. Motor is phased properly. Now if all that's good, before we tune, we can confirm that we're holding position. And if I rotate the shaft a little bit, there's a little bit of error. I can jog the motor, press and hold the positive button, it goes forward at 50 RPM, and reverse at 50 RPM. That's good. One thing that is important is to enable the amplifier. The default configuration for in1 is low to enable with clear faults. By default it's pulled up to 5 volts, so our drive is hardware disabled. So even if we software enable, we're still hardware disabled. So we have to pull that low or connect a switch to the input to get it to enable. And that's it. Thank you.